doing the next lesson under real numbers, which is our unit, is going to be estimating irrational numbers today. And we are going to estimate irrational numbers to the nearest integer. And our learning target, again, this one is going to be in module 5. This is lesson 5.3. And our learning target is I can estimate irrational numbers by approximating their locations on a number line or by truncating their decimal expansions. So the vocabulary that we are going to learn is truncating. All right, we'll talk about that. And then we'll discuss the difference between truncating and rounding. All right. So let's look at the first one, estimate to the nearest integer. And we are going to estimate square roots and cube roots to the nearest integer in this lesson. And so if I look at square root of 8, first and foremost, you know that the decimal expansion of an irrational number, it never repeats nor terminates. All right, it's not repeating, it's not terminating, and that's what makes it an irrational number. Okay, so to write the decimal expansion of an irrational number, you can denote an approximation using the symbol this. Okay, and this again, what does this mean? We've talked about this before. This is an approximation symbol. This is an approximation symbol. Okay, so and we are going to use more place values to give more accurate approximations. Okay, so let's look at the square root of 8. Let's look at the square root of 8. Okay, so first we have to think of which numbers that are right before and right after square root of 8 would be perfect squares. Okay, so perfect squares are like, what is 2 squared? Okay, so I'm going to write it here so that you can see what perfect squares are. So what is 2 squared is going to be 4. What is 3 squared is going to be 9, because 3 times 3. What is 4 squared is 16. 5 squared is 25. All right, so when we don't have that decimal portion and we get an integer, okay, that basically, these are perfect squares. Okay, that means if I do, what is the square root of 4? I'm going to get 2. What is the square root of 9? I'm going to get 3. Square root of 16 is 4, and square root 25 is 5. 36 is 6, and so on. All right, so that is what perfect squares are. Okay, perfect squares. Right, so then we do this, we will get an integer. Okay, now let's look at the square root of 8. Okay, so if I look at the square root of 8, we are going to look at, when we're doing an estimation, we're going to look at what number is a perfect square right before this and the number which is right after this. Okay, so if I look at this one and I know that this square root of 8 is going to be more than the square root of 4, because 2 squared, right? So this is going to be more than the square root of 4, but it is less than the square root of 9. Right? So that's the first thing we are going to do. All right? So the two perfect squares are what over here? Are 4 and 9. These are perfect squares. Okay? So once we have this done, we are now, I just want to show you with graphing. Okay? We know that the square root of 4 is 2, because 2 times 2 gives me 4, right? The square root of 9 is 3. Okay, we know that much. So if I am going to go ahead and let's say I graph this on a number line, Okay, and if I have something like this, 1, 2, 3, 4, 5, etc. Okay, so I know that the square root of 4 is what? 2. So this is my square root of 4 over here. Okay, and then I have the square root of 9, which is 3. Right? So as we can see, this is my square root of 4. This is my square root of 9. Okay, let me just make it with the black. You can see it better then. All right, here we go. All right, and so if I'm looking at the square root of 8, it's going to be somewhere here. This is going to be the square root of 8. Obviously, that's going to be closer to the square root of 9. All right. So I'm just showing this to you on the number line. Since square root of 8 is closer to the square root of 9 than to the square root of 4, okay, this is how we have graphed it. So we know that we can approximate this, and we can say the square root of 8 is approximately what? 3 as the integer. Okay, because this is much closer to the 3 than to the 2, as you can see. All right, and we can say square root of 8 is closer to square root of 9 rather than square root of 8 being, it's not that close to square root of 4. So that is why we are just going to give an approximate value. And since this is closer to square root of 9, square root of 8 is closer to square root of 9. So therefore, my answer would be 3 in this case. And that's how we are estimating to the nearest integer, okay? Depending upon the proximity of the number, all right? So let's do, how do you know that square root of 8 is between 2 and 3? And how do you know that square root of 8 is closer to 3 than 2? So again, as I just said, square root of 8 is between square root of 4 and square root of 9, since 8 is between 4 and 9. And 4 and 9 are what? They are perfect squares, above and below 8. Since square root of 4 is 2 and square root of 9 is 3, square root of 8 is definitely closer to square root of 9 than square root of 4. Since 8 is closer to 9 than 4. Okay, and so since square root of 9 is 3 and square root of 4 is 2, then square root is closer to 3 than 2. And so this is just a refresher of what I just talked about. All right, so now let's carry on, and we are going to do problems based on what I just said. Okay, so now let's look at this one. And we are now going to solve. Okay. So it says estimate square root of 83 to the nearest integer. Okay. So we are going to first look at the greatest perfect square, which is less than 83. And what is less than 83 is square root of 81, which is equal to 9, right? So square root of 81, which 9 times 9 gives me 81. So that's the perfect square, all right? And so this is the greatest perfect square, which is less than a square root of 83. Okay? And then I have the least perfect square, which is greater than 83 is what? 100, right? Because 9 times 9, and then I have 10 times 10, which gives me what? 100. So this is the perfect square. All right. So now what we're going to do is we are going to, again, we can plot this on a number line. Okay. And so let me show this to you. So if I have 9, okay, and I have 9 and 2500th, 9 and 50 hundredth. Okay, so we can just do it this way. 9 and 7500th, and then we have 10. Okay, now I know that square root of 81 is going to give me 9, and square root of 100 is going to give me 10. All right, so if I have square root of 83, it's going to be here. Okay, it's going to be square root of 83 is going to be here. Okay, so now I just wanted to show this to you on the number line, and now we are going to estimate the square root. And I know that we have 81 is less than 83, which is less than 100. All right, so we're going to write an inequality like this, and then we know that 81 is equal to 9 squared is less than 83, and we know that 100 is equal to 10 squared. Right? So next what we're going to do is we're going to find the square root of each number. Okay, so square root of each number. Okay, so this is what we're going to do. And then after that, we are just going to simplify. All right. So square root of 9 squared is 9 is less than square root of 83, which is less than 10. All right. So now, since square root of 83 is between 9 and 10, since square root of 83 is closer to square root of 81, look how close this is compared to with this distance. All right, so that is why the best integer estimate for square root of 83 is going to be 9. All right, so the best integer estimate, so when we write an estimate, 83 is approximately 9. So if when we are doing the integer estimate. All right, so this is how we just show our work. All right, now let's do a problem where we're taking this same number, which is square root of 83, and we are going to estimate square root of 83 to the nearest 10th. Okay, this was to the nearest integer. Now we are going to estimate to the nearest 10th. Okay, to the nearest 10th place value. Okay, so we have already seen that 83 is much closer, a square root of 83 is much closer to what? Square root of 81, right? And so what is the square root of 81? That is 9. Okay, much closer to this than to this. So this is what it's very close to. And we just saw that. Okay, so what we're going to do is we are going to test intervals which are close to 9. And so we're going to start with the interval between 9 and 9 and 1/10. So that's what we're going to do first. So we're going to take 9. All right, and we're going to say is less than square root of 83, which is less than 9 and 1/10. Because now we are trying to go into, we're going to write an inequality. And since we are estimating to the nearest 10th now. So once again, since square root of 83 is close to square root of 81, which is 9, we are going to start taking values for 9. Okay, it's too far from 10, so it's not going to work. All right, so we'll start with 9 and 9 and 1/10. If that doesn't work, we will go to the next one, which is 9 and 1/10 and 9 and 2/10. And then we'll see where does 83 fall, the square root of 83 fall. Okay, so let's look at this. We're going to write it. We wrote this inequality, and now we are going to square the values. Okay, so we have 9 squared is less than square root of 83, which is less than 9 and 1/10 squared. Okay, so we are going to square these values. It's going to square all the values. All right, so what is 9 squared? Is 81. Is less than what is square root of 83 squared? Is going to be 83. Is less than 9 and 1/10 times 9 and 1/10 is going to give me 82 and 81/100. Okay, so let's look at this. Is this inequality true? No, this part is correct. 81 is less than 83. But is 83 less than 82 and 81/100? No. So this one is not going to work. All right. So let's test the next interval now. So we are going to, so this was 9 and 9 and 1/10. Okay. So next interval that we are going to test is 9 and 1/10 and 9 and 2/10. Okay. So this here we started with 9 and 9 and 1/10. Okay. So let's start with this now. So we're going to write the inequality again. We have 9 and 1/10 less than square root of 83 less than 9 and 2/10. Okay. Then after that, we are going to square the values. 9 and 1/10 squared is less than square root of 83 squared less than 9 and 2/10 squared. Now we just did 9 and 1/10 squared is what? 82 and 81/100. Okay. Square root 83 times square root 83 is just going to give me 83. Is less than 9 and 2/10 times 9 and 2/10 is going to give me 84 and 64/100. All right. So now look, is this inequality going to be true? All right. So if we are going to see this, is 82 and 81/100 less than 83? Yes. Is 83 less than 84 and 64/100? Absolutely. So this inequality is true because 83 is between 82 and 81/100 and 84 and 64/100. So therefore, square root of 83 is between 9 and 1/10 and 9 and 2/10. All right, if we are estimating to the nearest tenth. Okay, so it's between those two numbers. And since 83 is closer to 82 and 81/100, okay, this is closer to this number compared to this number. Okay, so therefore, if we are finding the approximate value and we are trying to see, we are estimating it to the nearest tenth. So therefore, what is it going to be? We are going to have square root of 83 is approximately 9 and 1/10. So this is what I have just put it in the 10th format. Okay, so here. So because this number is closer to this compared to this one, so therefore I am going to do an approximation, and square root of 83 is approximately 9 and 1/10. And that is my answer, rounded to the nearest 10th place value. All right. Now, let's estimate cube roots to the nearest integer now. Integer. So integer has to be a whole number. It is not, it does not have a fractional or a decimal part. Okay. So now let's do cube roots. All right. So let's take 320 cube root. And we are going to estimate 320 cube root to the nearest integer. All right. So we are going to find two perfect cubes between which 320 lies. And then we are going to find their cube roots. Okay, so when I'm talking about the three perfect cube roots, so think about it. If I'm doing perfect cubes, all right. So if I have, let's say, the opposite of the cube is going to be this, which is 2 times 2 times 2, which is 2 times 2 is 4 times 2 is 8, right? Then I have 3 cubed. So the cube root of 8 would be what? This, right? So 3 times 3 times 3. 3 times 3 is 9 times 3 is 27, which is here. These are the perfect cubes, okay? So it would be 3 for this one, all right? And so we keep on like this. We have 4 cubed. Just thinking about all the cube roots which are as close as possible to this one, okay? So 4 times 4 times 4. 4 times 4 is 16, and 16 times 4 is 64, right? Here we go. And so then we have 5 cubed. 5 times 5 times 5, which gives me 5 times 25 times 5, 125. Right? So the answer would be the perfect cubes in this case. This would be 3. 2. This would be 3. This would be 4. This would be 5. Let's try 6 cubed, and what we get? 6 times 6 is 36 times 6, and I get 216. 216. So my answer would be 6 for this one. And then let's try the perfect cube, for 7. We have 7 times 7 times 7. 7 times 7, 49 times 7 is going to give me 343. Okay, so therefore, let's look at this. We are looking at the cube roots, the perfect cubes which are between which 320 cube root lies. So if I'm looking at over here, I can see these two numbers, right? So it's going to lie between 216 cube root, okay, and 343 cube root. So let's go ahead and quickly plot this just so that you can see what I'm talking about. Okay, so if I have this, I have 6, 6 and 2500, 6 and 5000, 6 and 7500, and 7. Okay, so now we know that, what did we have over here? This is 6 is what? A 216 cube root, right? So this is 216 cube root, and 7 is 343 cube root, right? So 343 cube. All right, now let's look at 320 cube root. So that is going to fall about here. Okay, so this is going to be 320 cube root. So now look at the distance. Which integer is this closer to? Is it closer to 7 or is it closer to 6? So just looking at this, I know that 320 cube root is going to fall closer to 7. So the approximate value of cube root of 320 would be 7. All right. But now we are going to write out an inequality to estimate the cube root so you can see. All right. So we have 216 is less than 320, which is less than 343. All right. And now we know that 216 is what? It is 6 cubed, right? Which is less than 320. And 343 is 7 cubed. All right. And so we are going to go ahead and find the cube root of each of these numbers. And so we have 6 cubed this is less than 320 cube root, which is less than 7 cubed cube root. All right. So what am I noticing over here? 6 is less than cube root of 320, which is less than 7. All right, so I have to simplify. So cube root of 320 is between 6 and 7. Since 320 is closer to 343, all right, the best integer estimate for cube root of 320 is going to be 7. Is going to be 7. All right, so that's how we estimate to the nearest integer. All right. So let's now quickly talk about truncating, since that was a word that we had talked about with the vocabulary. What does truncating basically mean, and how is it different from rounding? So that's what we're going to talk about. All right. So let me go ahead and erase this first. All right. And let's talk about truncating. You can estimate irrational numbers using a calculator by truncating the decimal expansion. Okay, so let's say I have square root of 12. So when I say truncating, it's a process of approximating a decimal number by eliminating all decimal places past a certain point without rounding. Okay, so if it says 10th, you'll go to the 10th place value and just eliminate everything else. But rounding is different because we look to the place value on the right, and then based on if the number is 5 or higher, the number rounds up. If it's less than 5, it stays the same. But that's what rounding is, right? But in truncating, we just go to that place value that is required and remove and eliminate everything else behind that. That's what truncating basically means. Okay, so if I had square root of 12 and I used a calculator to find this, I would get approximately 3 point, and then 4641 if I'm using a calculator, 1615, and so on to the so if you're going to truncate this, all right, so let's talk about what place values. So if I am truncating this to the 10th place value, if I am truncating this to the 10th place value, what I'm going to do, I am going to do this is going to be approximately, what were the numbers here? Here, with the calculator, this is what I was getting. Right? So truncating basically means if I'm saying 10th, I'm just going to look at the 10th place value, which is the 10th place value, this one. The number right after the decimal is the 10th place value, right? So what am I going to do? I'm going to remove everything else. So my answer in this case, if I'm doing 10th place value, would be approximately 3 and 4/10. Okay, if I was doing the 100th place value, okay, so if I was doing the 100th place value, again, I would take square root of 12 is approximately, let's look at these numbers. Okay, so I would take, let me just show you what I'm doing. 4641011615 la la la. Okay, so now I'm going to look at, okay, where's the 100th place value? So I know this is 10, this is 100. So if I'm truncating, I'm removing everything else after that. No rounding required, nothing. Just eliminate everything after that place value. And so for the 100th place value, this would be approximately 3 and 4600th. All right. If I was truncating to the 1000th place value, okay, if I was truncating to the 1000th place value, so 1000th, okay, so square root of 12 is approximately 3.4641011615, etc. Okay, so if I'm looking at the 1000th place value, where am I going? This is 10th, 100th, 1000th, everything else gone. So square root of 12 would be approximately 3 and 464 thousandths. So that's basically what truncating is. All right, now let's compare this to rounding really quick. So let's say I was rounding a number, this number, to the 10th place value. Okay, and see how truncating is different from rounding. So if I was rounding to the 10th, just showing you the difference. Okay, I have 12 is approximately, square root of 12 is approximately 4101615. Okay, so if I am rounding this, all I would do is, if to the 10th place value, this is to the 10th, okay, I would have to actually look at the 100th place value to round. So for rounding, I would look at the underline the 10th, I would circle the 100th. Is 6 greater than 5? Yes, it is. So because 6 is greater than 5, I would actually round this, and this would become 3 and 5/10. Okay, if I was rounding to the 100th place value, it would be 3 and 4600. Because is 4 greater than 5? No. So since 4 is not greater than 5, the number stays the same. Same thing with the 1000. If I was rounding, it would be 3 and 464,000, because 1 is definitely not greater than 5. So that's the difference between rounding and truncating. In rounding, we look at the number to the right of the place value. If it is 5 or higher, we round that place value up. If it is less than 5, it stays the same. Whereas where truncating is concerned, there's no rounding going on. We are eliminating everything behind that place value. So that's the difference between rounding and truncating. Okay, so um, let's see if we do one more problem, and this is going to be our last problem. I'm going to take you to my whiteboard for this one. All right. So we are going to estimate by truncating. We're going to estimate by truncating. All right. So Wyatt wants to fence in a square portion of the. All right. Just move this out of the way. So let's look at this. Wyatt wants to fence in a square portion of the yard to make a play area for his new puppy. The area covered is 2 square meters. Okay, this is the area, is 2 square meters. How much fencing should he buy? So obviously, if I am looking at the amount of fencing, we are looking at nothing but the perimeter. The perimeter. Okay, for me to fence around. So what is the perimeter of this? It is going to be 1, 2, 3, 4, obviously, right? Because it's a square. So if I'm finding the perimeter, is going to be what? 4 times square root 2 meters. And that's how much of the fencing I'm going to need. All right. So we are going to approximate 4 times square root 2 by first truncating the decimal expansion of square root 2 to the nearest, to the 10th place value. So we are going to use a calculator. So first we're going to look at this part. All right. So I'm going to truncate it. So if I have square root of 2, this is approximately, and I'm telling you what I'm getting with a calculator, I'm going to get 1.414 13562. 13562. So this is what I'm getting with a calculator. However, we are only interested right now. We are going to just estimate to the tens place value. So that means I am going to say square root of 2 is approximately, what is the 10th place? This one, right? In truncating, do I need to care about whatever is behind that place value? No. So all I do is eliminate everything else. And so I'm left with 1 and 4/10. Okay. So I know that square root of 2 now is going to be between 1 and 4/10 and 1 and 5/10. Okay, so I'm going to find the amount of fencing. Since square root of 2 is between 1 and 4/10 and 1 and 5/10, the perimeter, which is 4 times square root 2, is between 4 times 1 and 4/10 and 4 times 1 and 5/10, right? Because that's what we found out the approximate value to be. So we are going to write the inequality. All right. So let me use a different color so you can see. All right. So I'm going to write the inequality over here. And I'm going to say that the perimeter, which is 4 times, and we said this was truncated to 1 and 4/10, right? This is less than 4 and 4 times square root 2, right? Because we had truncated it, which is less than 4 times 1 and 5/10. So it's going to be between these numbers. Okay, so what is 4 times 1 and 4/10? I am going to get 5 and 6/10. All right, which is going to be less than 4 square root 2. All right, which is going to be less than, what is 4 times 1 and 5/10? I'm going to get 6, or 6 and 0/10, same thing. All right, so after multiplying, this is what I get. Okay, so 4 times 1 and 4/10 is 5 and 6/10, and 4 times 1 and 5/10 is going to give me 6. All right, so Wyatt will need between 5 and 6/10 and 6 meters of fencing. So therefore, obviously he should not have less amount for the fencing. It's better to have a little bit more, otherwise we'll have a gap left, right? So you always, when you're buying stuff like curtains or fencing or material to stitch something, you don't want to have less, you want to have slightly over. So therefore, for this case, he should buy 6 meters of fencing. He should buy 6 meters of fencing. All right, and so that would be the answer for this problem. All right, so again, why will Wyatt need more than 5 and 6/10 meters but less than 6 meters for fencing? Because Wyatt needs exactly 4 times square root 2 meters of fencing. And by truncating, what happened? The decimal expansion, we got 4 times square root 2 is between 5 and 6/10 and 6 and 0/10, and so he needs more than 5 and 6/10 meters but less than 6 meters. Okay, now could you truncate the decimal expansion differently and explain how it would affect the answer? So yeah, we can definitely truncate the decimal expansion differently by, we can go to the next place value, which would be the hundredth. thousandth. So the more place values you are adding, the closer it is going to be to the actual amount. So we are going to let's say if I was truncating to the hundredth place value. So this is what I had. So then my hundredth would be what? If this was hundred, okay, if it's a hundredths place value, I'm just telling you, uh, this would be approximately 1 and 4100th, right? And so if that was 1 and 4100th, I would look between 1 and 4100th and 1 and 4200th. And so I would multiply that with the 4, just like I did here. Same thing here. But only thing is over here, this would become 1 and 4100th. This would become 1 and 4200th. All right. And so when I do that, I would actually get 5 and 6400 and 5 and 6800. And so in that case, he does not need to actually buy 6 full meters, because he could have just bought 5 and 6800, which is closer to basically what he needs. Okay, so he could buy less in that case. All right. So that's basically what this entire lesson is about, where estimation of irrational numbers is concerned. Find the perfect squares or find the perfect cubes, and then see between what it lies. And then if it is asking you to around to the 10th or 100th place value, etc., go ahead and truncate it in order to see where would the number not round, where would the number be closest to in your estimation by the distance from that other number. All right. And so that would conclude our lesson 5.3. Have a great day, everyone.